welcome. So in this section, we're going to be talking about acceleration. Now, acceleration is the next step in our understanding of motion beyond velocity. So we discussed position. We discussed how if you change position, that's called a displacement. If that displacement occurs over some period of time, that's a velocity or average velocity. Now, what happens if you change velocity? Well, acceleration, and we'll be using the lowercase a to represent acceleration, is the rate at which an object's velocity changes. So how quickly you change velocity is an acceleration. And we have some general understanding of acceleration, right? You understand that if you've driven a car, you push on the accelerator, right? You push on the gas pedal, you feel the acceleration, you feel being pushed back into your seat. Or if you brake quickly and you change velocity from a high velocity to zero, that is an acceleration as well. So the rate at which an object's velocity changes. So if the object's velocity changes quickly, it's a large acceleration. If it changes slowly, it's a small acceleration. Now, note, velocity is a vector. So normally when we think of acceleration, we think of changing speed. And that is an acceleration. If your speed changes, you are accelerating. However, it's the velocities change. So not only is speed important, you're also accelerating when the direction of motion changes. So think of a car driving on a highway and you have cruise control on 65 miles an hour and you're driving along the highway and you come to a curve in the highway. Well, if you have your cruise control on, your speed doesn't change, right? You stay at 65 miles an hour. However, you're going around a corner, so the direction of motion is changing. So you are accelerating. So if you imagine a car on a circular racetrack going around at the same speed over and over and over again, that car is accelerating because its direction of motion changes. So acceleration has two parts to it. The first part is it can change an object's speed. The second part is it can change an object's direction of motion. And of course, speed and direction of motion together is a vector we call velocity. Now, the average acceleration, or it can change both as well, of course, it can change speed and direction of motion as well. Now, average acceleration, like average velocity, is that rate change over some period of time. So it is average acceleration here, a with a bar above it, is the change in velocity over the change in time. Now remember that velocity is a vector, so acceleration will also be a vector. Acceleration direction is important. If you're driving north on a highway and you accelerate to the north, your speed will increase to the north. If you're driving to the north on the highway and you accelerate to the south, your speed decreases. So depending on what direction the acceleration is applied will give you a different outcome. So acceleration is a vector. It has units of meters per second squared, right? It's a rate change of velocity. Velocity is meters per second. So it's meters per second for acceleration, which reduces down to meters per second squared. That's SI. English would be feet per second, and so on. So the average acceleration is given by this relationship. Now, acceleration, because it has a colloquial definition, which is slightly different than the physics definition of acceleration. There are a couple of terms that we need to come to term with that might differ on how we describe acceleration. Well, first of all, I'd like to point out again, velocity, acceleration is a vector. It points in the direction of the change in velocity. So if the velocity is increasing in the positive direction, the acceleration is pointing in the positive direction. If the velocity is decreasing in the positive direction, the acceleration is pointing in the negative direction, and so on. Acceleration has both direction and magnitude. It is a vector. Now, when I talk about negative acceleration, and when your book talks about negative acceleration, it just means acceleration that's pointing in the negative direction of your coordinate system. So for example, if we define the Cartesian coordinate system Positive is to the right, negative is to the left in the horizontal direction. Positive is up, negative is down in the vertical direction. So if I drop this marker, right, it accelerates in the negative direction because we've defined down to be negative. Since it accelerates in the negative direction, we call that negative acceleration. So if I have a car, my art skills are awesome as always. If I have a car that's at rest, but then I have it accelerating to the left, so it's speeding up, this is still a negative acceleration because the acceleration is in the negative x direction. So negative acceleration has nothing to do with whether it's speeding up or slowing down. It's just the direction of the acceleration with respect to your coordinate system. That's different than the next definition, the term deceleration. Deceleration is not often used in physics, but it's often used in colloquial language. When you deaccelerate, your speed slows. So it's hitting the brakes in your car. Technically, according to physics, that's an acceleration because it's a change in velocity. But our brains don't, like, wait a minute, I'm not accelerating, I'm slowing down, I'm decelerating. Physics, acceleration is just a change in velocity. It doesn't matter if the velocity is changing direction, if the magnitude of the velocity or its speed is increasing, or if its speed is decreasing. All of those are acceleration. When I throw this marker up and it falls back down, it is accelerating all the time. Here the speed slows, it's accelerating downward, and here it falls and begins to pick up speed, it's still accelerating. But colloquial language, when something slows down, we call it a deceleration. So deceleration has to do with the object's speed, not velocity. If the speed, which is the magnitude of the velocity, if the speed is decreasing, we say it's being decelerated. And then finally, instantaneous acceleration is just the acceleration of an object at a particular instant in time. It's very similar to average velocity and instantaneous velocity. Average velocity is a velocity between 2 points in time. It's just two displacements at 2 different points in time. That's the same as average acceleration. Instantaneous acceleration is the acceleration of an object at a particular instant in time. So imagine you're driving your car and you're just hitting the gas pedal, letting off of the gas pedal, hitting the gas pedal, letting off of the gas pedal. Your acceleration is constantly changing with time. And if you know what that acceleration is at a particular instant in time, that is the instantaneous acceleration.